I'd like to talk about ultraviolet wands. You see them advertised all over the place, touting their ability to kill or at least disable microbes and microorganisms, including the SARS-CoV-2 virus. The question is, how do we know they work? All you see is an ultraviolet type of light, which isn't really the light that does the killing. And let me emphasize here, it doesn't kill. It just disables reproduction by affecting the DNA, but that's another video. So the question is, how do we know these things are real and they're not just light bulbs with a bluish tinge? Well, there is a way of testing this, and it requires a meter. And here's a meter that I use. It measures UVC light in microwatts per centimeter square. Here, I hold a wand about an inch from the sensor, and the display shows approximately, well, shows exactly 588 microwatts per centimeter square of intensity. I use a block here to hold the button engaged, because otherwise I'd have to put my hand underneath the light, and ultraviolet C can damage skin. On the right-hand side here, I put a piece of glass. It comes from it's actually a slide from a microscope, in between the sensor and the wand. And you can see here that the display is 0. Glass and many kinds of plastics block UVC rays. Okay, so if you were to look at one of these light bulbs with your eyeglasses on, it won't damage your eyes, but it will damage the skin surrounding the eyeglasses, so be careful. But this is one way of proving that this meter is actually working. Because during the daytime, when I point this meter up at the sun, I see a 0 display. Well, I expect to see 0 for the UVC, because that wavelength never reaches the Earth. It's blocked by the ozone layer. But the fact that it reads 0 during daylight means it's also blocking UVA and UVB. The reason I bring this up is because to really understand this experiment here, it's totally possible that this light bulb is still fraudulent. Say it doesn't have any UVC. It only has UVA and UVB. Well, the glass blocks it, and that doesn't prove anything. I should really say that just because it shows 0, it doesn't prove that this wand is emanating UVC, because the meter itself cannot read UVA and UVB. It filters it out. The proof is here that it does react, and only reacts to UVC. During the daytime, this was 0. So this is your proof that this particular wand does what it says it does. It's producing the germ-killing UVC bandwidth, wavelength. Let's do a little bit of a calculation here, and to see what this means. Now, I mentioned in a previous video that to disable the SARS-CoV-2 virus, it takes 40 millijoules per centimeter square of a dosage. So the equation we'll set up here is 40 millijoules per centimeter square equals, now here we have the intensity, and that's 0.00588 watts, or 588 milliwatts per centimeter squared times time. What I'd like to know is, if I were to use this wand to disinfect a dollar bill or a credit card, at 1 inch, how long would it take? So here's the equation, and we have to solve for the time, seconds. All right, that would equal 0.04 watts times second, which is a joule, per centimeter squared, times centimeter squared over 0.000588 watts. Now, if you don't understand what I did here, please refer to my other video explaining the calculations. The centimeter squares cancel, the watts cancel, and we're left with 0.04 over 0.000588 times seconds. Notice the seconds did not cancel. And I think that's about 62 seconds, approximately. What does that mean? That means that if you were to use this wand at 1 inch from the object that you'd like to disinfect, it would take 62 seconds. If it's a dollar bill, that would mean it would be 62 seconds on each side, because the germs can only be affected if they are in the direct path of the light. They don't respond if they're in the shadow. So you'd have to turn that bill or that credit card over onto the other side. So these wands work. And, for a small wand like this, it's not unreasonable to spend a minute, 2 minutes to disinfect something in a pinch. Of course, there are more powerful bulbs, and I give an example of that in my other video. But I would say that it's not a bad investment. Thank you for watching.